So first thing, you need to aware of iterables. So we have already seen about iterables. What are they? How they can help us, and everything. Iterables means what? Any function which supports for loop on it is called as an iterable. Then, like, what are the existing iterables that we have? So the basic things, if you see, like int, float, none, boolean, true, all those things are non-iterables. Then if you go further, so I told you about these things. So where like string, list, full, dictionary, set, diction, all these things are iterables. Means you can apply for loop on them. But if you apply for loop on, let's say, on integer, you see, for so number in, or like, for digit in some big number I took, it is an integer. So if you try to ask, hey, print one value at a time, and it will throw an error because it cannot go to each of the character at a time and do it, right? That's the biggest problem there. So it will throw an exception. So that is a problem. So as it took like, the first time, it's taking much. Yeah, see here, we cannot do. Whereas you can apply for loop on any other data types. So if the same thing is in quotes, then we can do it. So if a same thing is in quotes, it's a string, so we can get it. So that is a iterable means. Similarly, you can apply on strings. So you can apply on list, tuples, and dictionaries, all these things, And also when you're applying for loops, I told you, the list, tuple, so sets, when you're looping, you will get each value at a time. Only when sets, when you're doing, you don't get the values in a proper order. It will just give in random way. So that's what we should be careful about. And also when you're iterating on a dictionaries, I told you one interesting point that, so when you loop over them, you will get like by default the keys of a dictionaries, right? When you by default loop on any dictionary, you get the keys only. So if you do dictionary.keys also, you'll get keys only. If you want values, you should explicitly tell. If you are into both keys and values, you go with items, right? That's what I told. But if you want to assign to two values, so that's what, so we need to assign to two variables. That's how we get it. This also I told you. And also, hope you remember, I told you about like when you're getting 2, 3, 4 values also, we can assign to multiple things and get it. You see, in this case, what is happening? So you have a list of tuples. So each tuple is containing 4 elements. Then I can assign to a single element, or else to 4 elements, or so 2 elements and the remaining like this. In 3 cases also, I can do the same problem. When I'm getting the values, I can assign like that. In the 3 cases, 3 different ways. So let me show you clearly. If I execute in the first case, each tuple is containing this entire tuple values in one variable. Whereas if I do the same thing, so using the second way, so I'm assigning to 4 specific variables and I'm asking. So 4 variables are created and storing. So what if you want to assign like 2 variables and third one? Means like what? So this first and second will become the individual values. See, first and second will have individual values. And as I placed a star, you remember star? I told this is unpacking, right? Asymmetric unpacking. As you did that, you got the remaining values to it. So that is how it works. And not only this, I told you about when you're doing iterables. So there is something like built-in functions. If you do like list, tuple, or set, it will go to each of the value and try to create a data structure from them. But if you try to do the same thing with a dictionary, then it will not work. Say if I say Python prog itself, if I do, dictionary won't do it. Because dictionary expects 2 values. So if you do 2 values, then it will do. But can I pass 2 values directly? No. It expects like a list of tuples. So we need to use a zip. And for that zip, you need to pass your iterables. Iterables doesn't mean that like, so to strings, to integers, anything you can take and do it. So it will create a dictionary out of it. So that is how we have seen all kinds of iterables. So then we have seen about enumerate. So this also I told. Enumerate means if you want to get the loop count, that's where we use enumerate I told. So let's say I have a string called so and so, and if I want to get the loop count of each time, so what I can do, I can say each character in so my string, I can tell like print off each character. It will print it. So what if I just don't want to print the character only, but I want to print the count also, means loop count. So loop count equal to 0. So every time I print the loop count, comma that character. So if I execute, every time I get 0 only. But within the function, if I do like loop count, so plus equal to 1, you see every time 0, 1, 2, 3 came, right? So instead of you creating a variable, you implementing addition every time. So you can do the things in much better way. So using enumerate function. Using enumerate, what we can do, so the same for loop you do. So instead of that, you pass to a enumerate built-in function. And you need not do this count every time. And you don't have this value, you just remove it. Now you see what will happen. Each time it is getting two values and you can do it. Now not only that, as every time you're getting two values, you can create a variable called as loop count here itself and use it. So again here you can write the loop count. You see now the loop count it is showing. You see it is going the loop count also. So that's what I told. So not only this, as I told you two variables, so like this we can do. What if you want the loop count starting with some other number? So that's where I told, right? In the starting, if I give like a start equal to minus 88, from minus 88 it will start. See 88, 89, every time it will go on incrementing. So that's what like loop number changes. What if I give like positive, say positive some number I give, it will take from that number every number. So this is what you are aware of. Whereas what we can't do with this enumerate is that you cannot give this offset, which is like a floating point value. If I say 12.3, it will say no, because it should be a number. So this is all you learn. Next, similarly, so we have seen about the bool built-in function, right? Hope you remember. I told the bool built-in function is there. So it is very interesting. So if you work with the bool built-in function, I told. So this it works differently for different data types, I told, right? So if you have like all integers, so or if floats, so how it works? If everything is 0, it results in false. Non-zero, true. String means empty string, it is false. Non-empty string, it is true. So braces means empty braces is false, others is true. Similarly, as we work with iterables right now, so for iterables also we have a rules, right? So for iterables to work, so individually, if I say like so bool of 1, I know that it is a true. So similarly, bool of 0 means it's a false. But what if I have a list of values and I want to check the bool of each of the values? If let's say I have a list of values, I want to check each of the value whether it is boolean true or false. Then what I can do? So for number in my list, I can check. So print of so number comma bool of number. You see now what happens? For every number you get a so number and boolean of number. So why I'm getting like this? For each of the number, right? Should say. Oh, yeah, I did a my underscore list. I should do. See. So it took like a previous values. Now you see, you got it. So for each of the number, it is saying true or false. What if you want to get only if they were true or only if they are false? So if that is the case, then what you could do? So you can write like this that hey, if boolean of number means if the boolean number of number is true. If that is the correct, in that case you want to print it. You see, only if the things are correct, you get it, right? So or else you want to check whether something is true or false. If everything is true, then you want to print, else you don't want to do it. So basically, all is a built-in function which will do the same thing. So means if I take like so my list, that if I pass to all, if I do, it will say false. So how it is actually doing in the backend means you take like for number in, so my underscore list each time. So it will check for each of the number. So if not bull of number means if something is false, either you can do like this or you can say that is false, right? So if it is false, then you want to print so which one it is false. So like that we can say. So and for that we can write a logic. Then we can say like break. So if nothing is done, then you want to go to entire loops and do. So this is what the logic I told earlier. Even for the for loop also we can have an else, I told. So like that we can have and check. So instead of you writing this much logic, all will do in one shot. Means simply to say, if all the values on that are true, then it will give as true. If anything is like boolean false, it will say false. So if you see now you understood. All values are true, but one of them is a zero. That's the reason you got like this. But for the same my underscore list, if I take like, so again the same numbers, even if it is repeated also, you got some numbers. Now if I execute the same thing, it will say what? So above result, which was like so and so, but like in this case, it's so and so, right? Result is like this. So like this is about all. And the next one is about any. Any means what is like, if any one of them is true, boolean, then it will say true. Any is a built-in function which will does the same thing. So here in this case, if you see how the implementation is there, if any one of them is true, it will say true. For that only I wrote the logic, but in real time you don't write this logic. So you just use any built-in function to get what you want. So if I execute, you can say any will be true. So that's what you understood. And now I can prove the same thing or different values. You see in this first case, to generalize, so all and any both will be true because everything is true, right? So all means at least one of them should be boolean true. So any means, so all means everything should be true. By the name itself, you can understand. So like that, if I say next example, in the first, all should makes that everything should be true. One of them is false, then result is false. Any means at least one of them is true, result is true. You see now? And similarly, so not only this, if I take a boolean, I know, if I say none, so for none also boolean will give a false, right? If one of them is false, all will be false. If at least one of them is non-zero, any will be true. So like that. So if I go to any things like this, say if I say booleans of, this is one of the interview questions actually. These were 4 interview questions actually. You see now what will happen? In the first case, it's a Python, it's a string, right? In the second case also, so as middle, so empty string, this is also empty also, sorry, white space is there, right? So white space is there. So that's why white space boolean, if you see, say what is a boolean of white space? Even if you give white space, it's a true. But if I say the same boolean of, so no content at all, empty string, then it is false. So this is all about you learn. So then after this, now after learning a brief introduction about all these iterables and so and so, so now we can say what is a iterator. So iterators means what? Any function which is like a design. Sorry, when you have, so till now to understand what is an iterator and how it works, first and foremost, you need to understand what is a range. So range is not a, so you need to understand this point. So range is not an iterator. But it will give you some idea about what an iterator can be and how it can work. Till now, what we know, range is a lazy loading object. For the first time using this word called as lazy loading object. What is this range? How it can work for us? If you can see, first let me take a one variable called as range of 0 to 9 with a step of 1. So the same range, if you do in Python 2, it is resulting in a list. So list of values will come. I told the same earlier also, now also I'm telling. If you print a range every time, it will tell what is the state. Means what is the starting value, what is the final value, so what is the step, how much I need to give the values. That's what it means. That's it. But any number of times you ask, as it is an optimized object, it will just tell like, okay, I am this much, I can do this much. That's it. See, I am values of so and so. It is of type also range type. Means if you want to get the values, there are two ways. Either you do a for loop on it to get one value at a time. So like this, you can get one value at a time by doing for loop. So, or like you can also convert to any other data types. So converting to data types means either I can convert to a list or a tuple or a set or anything, right? If I convert to list, the numbers result, you got the list of values. Similarly, if I convert to a tuple also, I get the tuple values. So like this, if I do to any of the things, I get. If I do like, tuple or a set also, I get the values, you see. So range is designed to get the values within that limit, right? You understood. But this is one of the interview question, that when you convert to a string, what will you get? When you convert a string, you are not extracting one value at a time. You're trying to convert to a string. So that's why you won't get anything when you convert to a string. So this is one point you need to remember. And what lazy loading tells to you, that it will not actually create the values, but it will store the state. Each time when you're asking a value, it will go and get the values from it. But if you convert, say for the same numbers, right? So numbers you took, like, you remember here, you created the word variable called as numbers, which has a range. You created once. So you asked what is the value, but like you did a loop on it, then you got the values. Again, you converted to a list, you got the values. Again, you converted tuple, you got set, so everything. So wherever you're converting or looping on it, you're getting the values. But you defined only once, but only on demand you are getting, right? So that is the beauty of this one. But what is an iterator, to be frank? So coming to the iterators, what you can understand is that iterators are slightly different. If you remember, so by now what we have learned, so those are all like the same. Means even if you see the results of a zip or a filter or a map, all these things, whatever we have learned till now, these are all the examples of the same. So means like till now we have indirectly used these iterators. So what are they? They are lazy loading or on demand. So even range is also like that. But range is not disposable. Means once you create and any number of times you ask, you get all values, right? Whereas iterator not like that. So once you get a value, that's it. That's the last. Means I'll tell you a simple example. So if I have like two iterables and I'm using these built-in functions, what we have now, zip, filter, map. If I have two iterables, like one is a set and other one is a tuple, I can do a zip of both of them, right? And I can ask, hey, what is the type and what values? When I ask type, it is saying that I am of type zip. Means for every iterable also, they are having their own types. And when you are masking the values, it is saying the object is located at this location. It is saying object is located at this location. That's it. No values. Then how to get the values? Same logic what I told earlier. So either you need to do a for loop so to get the values, or like, so we need to do the looping on, sorry, converting to other data types, right? So okay, first time I will do like a looping. I get each of the values. You know how zip works, right? It will give a list of pairs. So each time based upon that you get. So exact position won't come because it's a set. We don't know which is the order, right? So whatever it comes, you get in an order. So how many you got? 4 pairs. Because minimum size length of among them is 4. That's why you get 4 values. That is fine. So now another method is what? Converting to other data types, like a list, tuple, set, and strings, right? So, when I convert to them, did you notice the slight difference? So when I converted, in list I get empty, in tuple I got empty, set I got empty. Of course, string, anytime you convert any iterable or anything, it will not create anything, just a string, right? So it is not doing anything. But what you understood here, so once you got, when you do a loop, means in for loop you got the values, but when you're converting to a conversion, you're not getting. What is the problem? If you can focus more, then you'll understand. I told that, so range is like a lazy loading object or on-demand loading. That's it. Range is not a disposable object, whereas iterators are disposable. So means once you get a values, you cannot get again. So once you got, again when you're asking, it won't give. Then how do we get again? Means again we need to reassign. You see, I reassigned again, right? If you see in the example, I again created the zip, means again created, and then I'm converting to a list. You see, now I get it again. So if you just ask again, I won't get again. So again, I need to convert and ask. So means like every time you reassign and ask. Okay, this time I again created a new one. I'm asking the values by converting to tuple. So again, so if you want to convert to like a set, the same thing. Again, I redefine and I'm asking again. Means only one time you will get. So of course, string is different, right? So when you do a conversion, so you get nothing because string actually doesn't loop into it. So after that, if you ask like, list of pairs, so you get the values because string actually doesn't loop on it. So, so why you are getting now means, so earlier in str function won't iterate. So that's why you got it. So this is how you understood, right? Sir, why these like this? Don't you think it's a difficulty? Yes. So they intentionally created this structure because for working with large data, as a data engineer, we work with millions of records. So when you're working with that much data, just imagine, so your RAM means your heap memory of Python should store all this data when you're processing. Don't you think it would be very difficult? And sometimes on top, there will be data leakages when you have too much data. To handle and avoid all these things, that's where we have it. So in fact, it is a boon when you're working with large data to go with iterators. So for all the building data types, we have it. So zip you have seen. And similarly, so if you go for filter map, that also same thing, right? So I told you. Now going back to the real iterators. So how do you create? Of course, zip is creating an iterator, that's fine. What if you have your own data and you want to create? That is the main thing, right? So for doing that, so we have something else. You see, there is something called as iter protocol. Till now, we are calling any built-in function as a function, right? But for the first time, this is one of the function, but we call it as a protocol. Protocol means a set of rules, like that you can think. So what it does, if you give any ordinary data type, so till now, you know about ordinary data types like int, float, so and so. Those are all non-iterables. Whereas if you know iterables also, what are the iterables I told? Iterables means anything that supports for loop on it. I told in the starting. Okay, these were the iterables. So for all these iterables to better manage, they came up with that. Means, so every time int, float are the minimum values only. Only one value like that. There is no optimization needed. But if you take a iterable, means like a list, a string, or a integer or a float, what is the maximum values that you can have? There is no maximum, right? It is not like one value. You can have any number of values. Then what if you have a very large data? And then how do you handle it? So what if like, when you have large data, then obviously it can crash this Python system. To avoid that, only for the iterables, they created this kind of iterators. What is the point is that how an iterator is created? Let's see. So first, if I take a ordinary list called as alpha, if I ask, hey, what is the values? It says I'm of type list. I get the values. And if I ask length, I get it. This is what, a typical list. You can index. So for a typical list, what we can do? We can do length, we can do indexing, we can do slicing. So string operations, we have a lot of attributes also, right? So if I say like, print of DAR of, so this alpha as a list, you have seen a good number of attributes are there, right? So we can do a lot of things with that. Fine. A lot of attributes are there. This is all a typical list. Now from this list, I want to create an iterator. So if you want to create an iterator from a list, so simple, whatever your list is there, that you need to pass to iter built-in function. That's it. The moment you pass to iter built-in function, so it will create an iterator, and you see from now things will change. If you ask, hey, what is the type? It says list iterator, means this iterator is created from a list. And what are the values? You get these things. Means if I try to do like, say like a length of this, alpha iterator, you can't do. So you can't do length, you can't do indexing. So what are you have done? Indexing. The similar, if I do indexing right now, if I say get the second value, it is saying it's not subscriptable. Means indexing is not sufficient, supported, means even you can't do slicing. The same thing, right? So to say that you cannot do any of these operations of what you have done on a ordinary things. In one shot, I'm placing there for you to better understand. Then, sir, how? If I say like, print of DAR of this alpha IT, if I say same like the original, I try now also. Here, see, if you see things which have underscores on either side, if I remove, did you see there is anything else left? No, you don't have any other operations on iterators. Then what, sir? What can we do with this iterator then? So whenever you have a large data to store, we can use it. So then what is the process? How to get the values? Same process what you did earlier also, the same thing. If you want the values, either iterate on it or loop on them to convert, right? These are the two ways. So first time if I do, I get the values. If I do the convert a list, I don't get the values because it's a disposable object. Disposable means what? First we need to define and ask. So only one time you can ask. Disposable means what? Single use, right? So only one time you can use. Iter of alpha, if I say, I get all the values. And similarly, I can get to the list or a tuple or a set. I can do that. I can again redefine and ask the values. And set how it works. So for all. So what are you create? So from that, I'm converting. So in conclusion, I first created a list. From that list, I created an iterator using iterator built-in function. And when I'm doing any integer operation, sorry, list operation, because it's a list, you can't do anything. So once it is created, the only thing that you can do it, we can get the values. If you don't want to do operations, just you want to use the variables, that's where iterators are useful. So it is not for like 1-2 values. When you go for a large thing, that's where it will help. So next thing. Okay. So why iterator data type is every time called as a list iterator? So why every time it's called as a list iterator? So because you have created from a list. So then, sir, if I create from a tuple, is it called as a tuple iterator? So let's see that. So if I go to the next section, you see, I created a list, same like you. So, and asking the type, it says a list. Then I created a iterator from that using iter built-in function. So original list is there. And when it is created a iterator, it's a list iterator. This is fine. Now, if I go ahead and create a iterator from a tuple, means I use a tuple, and then I created a iterator from the tuple. Now see, it is of type tuple, and as it is created from tuple, it says tuple iterator. Similarly, if I take like a set, and from the set I want to create a iterator. You see, I defined in flower braces, and I'm asking. It says yours is a set iterator. Similarly, if I go for a dictionary, if I define a dictionary, that is very, very interesting. So dictionary by default, when you loop on it, what you will get? You will get only the keys, right? So if you want values, you should explicitly tell values. Or like if you want items, you can specify that. So like that. So from a dictionary, when you're creating just alpha, you get like dictionary key iterator. When you do dot keys also, you get the same thing. But if you say dot values, dictionary dot values, you pass to it, then you get dictionary values iterator. And if you pass items, you get item iterator. So did you see? These many types of iterators we can create. So, and not only this, and if you pass like, what are the other iterators we have? String. String is another iterable, right? If I pass, it is called a string iterator. And now in latest Pythons, they created like string ASCII iterator. So earlier it used to be only string iterator. Now maybe like if I take in non-English characters. So if I take like something like alpha or something, if I take like non-English characters, maybe I should get a non-English also. So you can take that as an assignment. String ASCII. So string Unicode iterator, you can try. So similarly, so this is all understood. Now going to this, apart from that, yeah, if I go further, there is one more thing called as the generators. So before understanding these generators, I will tell you a short story of why we are coming here. So iterators are for like thing. So if I go here for the generators itself, I can tell something else that. So till now, the conclusion that we can say is that we have gone for different data types. So both iterables and non-iterables I told. Non-iterables are like just variables. So there is nothing we can do. So they are already optimized. So that's fine. Whereas iterable objects means like these are very large data it can store. Then obviously, when you have large data, it is very difficult. That's why to better manage, so we need to have some kind of strategy. Range was already created like that to be like an optimized object and lazy loading. When even if you do 1 crore also, it will not generate all the values and store in your memory. So there is no much burden on your RAM. So whereas for iterables, all other iterables, we have iterable function. That's what I told right now. From string, if you convert it, string iterator, list iterator, dictionary, you have dictionary, key, value, and item iterators. And all these things are fine. But what if user-defined functions are there? Means in a function, if you have, within the function, say you created a code in such a way that it will create, say, 1000 prime numbers. But if you are using only 10 among them, then what is the point of going there? So it's not needed, right? So that is called as a generator. So generator, same like this. Now you are just expecting like, you pass the values, you get one at a time. So whereas in a generator, so we can do in top, you can write your logic what you want also. Let's say typically I have my own function called as like function, define function, and say like, hello world. So similarly, if I do like function call, if I call, you get like this, right? Your function. Similarly, if you have a generator, so I'm writing with the same name so that you can understand. Hello world. So is it called as a generator? No. So typical function, you can have like this, or you can have also in the other way. Let me show you. A function can have no return. When you don't return also, by default, it will be none will be the return that you know. Or you can have the same function with return of something. Say instead of printing, say I'm doing hello world. So I'm commenting it and I'm printing hello world. So they say if I do like this, what will happen? Say before even going to generator, if I do, what happens? In this case, when I'm executing the same function, say function 2, you see it is executing and returning this value, right? That's where you're seeing. Whereas in the same logic, I will do again, this time with a generator. If I execute, generator means same like your function, but instead of a return, there will be yield. What this is a new keyword you need to understand. See, the same function, nothing different. So instead of a yield, return, there will be yield. So the moment you have it is called as a yield. Okay, In the same generator, so let me write a hello world. So in this earlier example also, I'm doing hello world print and I'm returning. So here also I will do like this. Say here, then I do see here, it will print hello world and also return hello world. So here also I do like a print and I return. So it is not executing. In fact, means if I assign this to some result to some variable, so the same example, result is equal to so and so, and I'm asking, hey, print result, type of result, and the result. Did you see what happens? So it is not printing also, right? Did you see function was not executed? Means when the function will execute means when you make a call. So what is saying? Hey, result, you cannot make a call. So generator, it's a function call directly executed, right? Whereas how to get the values then? So you need to use something called as next is another built-in function. If you do, you get it. Giving one more example for you to understand. So define generator 2. I have some function. So I will say like, so first statement, and I do a yield. Say yield 100. I do. Okay. Now if I say I'm making a call, generator 2. So till now, a function, when you make a call, it will execute and give the result. Whereas in this case, even if you execute also, you won't get the result. Means it is not executing. In fact, it is a lazy loading. So you make a function call, it will not execute. If you ask for the first value, then it will execute. So how to get the first value? So you need to make a call like this. Means first the result you need to assign to some variable called as generator. And for that, if you do like next of result, means it will give. So now you see it has executed till the first statement and you got the result. The same example, I go further. Further I go. So this time I write like second thing. So print of second statement. So yield 200. Now you see here, I assign the result to something. So each time I assign what are the values I get and I print it. Print of f of, see, next of result equal to. You see, 2 times I am asking the values. You see, now what will happen? When I'm executing the first statement, I got the first print statement, mean it all gone here and did it. And next time asking for second value, it has gone resumed from it. Means the point is very simple. It's like state suspension mechanism. State suspension mechanism means like, so it will go execute till somewhere and it will pass. And again you ask, it will execute from there and pass. So means every time you make a next, it will go and get the value from there onwards. Means a for loop, typically what will happen? It will execute all the values in one shot. Whereas this will execute like this. If I again take this time a 4 values, these much generators, and if I ask values, you see now, so if I make a function call, nothing will happen. So this time you see, I created a generator. So with like these many statements, and I'm making a function call like an ordinary function, I don't get anything. So when this generator will start executing, the moment after asking one first value, so each time I try to ask for a value, say, next of result, I get executed. See here, the moment I ask, it executed for the first value. Again, if you ask like next of result, you get the next value. So again, if I ask like, next of, so result, I got the next value. So again, if I ask like result of next value, I got the next value. So, like that every time. Okay, I will ask again one more result. I get the next value. Oh my God, I got a stop iteration extract. Why this? So why I got these many values and suddenly I got this? Because as you created, so 4 yields, only 4 times you can ask next value. After that, if you ask, so and it will throw an error. So what is the exception called as stop iteration? And so is it recommended to have a return in the last? it is optional. In fact, Pipette says don't use it because you are confused. But if you want the stop iteration exception, when all the values were done, if you want some error message, that message you need to place here. If I do it, so whenever I'm calling, after this, let's say after these 4 statements, you get an exception. Sir, I want to execute, but I don't want this exception to happen if I just want to get the values. So then traditionally what you did for an iterator, you can do the same thing here. Means you can tell like, so for value in result, so print value. Did you see now this time? So instead of going each value one at a time, you are doing a for loop. Did you see? It will execute initially and it will come till yield and it will pass. Next time when you're asking, it knows earlier till where you asked. From there it will go till next. From there it will go till next. From there it will go till next. So like that you can do. And then if I do like convert to a list, what will happen? This is also another way, right? You can convert to list or a tuple or anything. You get nothing because this is also a disposable object. Once you create, that's it. Again, if you want, again you need to, so again you make a call. So then convert to a list of result. You got it? All executions and get end result. So see, that's the beauty of these things. Then in which case we use these generators. So whenever you have large data to be processed, so means like I told, right, complex things and so and so. That's where we use it a lot. So let me go with one more example where you can better understand these things. Say, let's say here in this example, initially printing the first statement, then I am doing a for loop of this thing. Each time, so before yield, after yield I am doing. Say for suppose there is a return. Return will be the last statement, right? So instead of return, I use a yield. So each time it will give the values and finally it will give it. And you also already know that if I do a function call, nothing will happen. Same like that. So if I ask here what is the values, it will say. And if I see DAR also, same like an iterator, it has some attributes. Did you see? Even a generator has attributes like send, throw, and all these things. These are used in a different context. So, but like the most common thing that we can use is, so either a next built-in function. So next of what are the end result is f is there, right? Like that you can ask, or f dot underscore next underscore. Which one do you prefer? Obviously next built-in function is easy, right? So that's what you prefer. So either way you can do, or like, so after getting, already it did it 2 times. So if you want to do beyond, so you can check in either way. So if I say next of f, so it will give again. So 3. If you after that, if I ask next, it will throw an error because all iterations were completed. So after stop iteration, you didn't get any message because here I didn't return anything. So default return is done. That is how it works. Similarly, so that what you understood is like if you go beyond and I want to ask every time, you need to have a stop iteration exception. We need to handle like this. If you don't want to do what I told is like convert to either convert to list or a tuple or anything, or do for loops. That's a smart way of doing. But so did you understand why I'm telling this much big thing? Because generators are designed to work with on large complex logics. Whenever you have large data to be done, so that's where you can do a generators. So the only advantage is your code will be much better with this. So after going to these generators, you understood, we can understand about modules, how to work with modules, what are the different modules, and how we will work on them. So now till now you understood about the basic data, how we work on it, and the next thing is about the modules. So the most important module that we work is, first is the math module. So then like we work on the OS module. So OH module we work. So then we work on next is like sys module. So like that we have like different modules we'll work with one after the other. So first to see what all these modules doing. So to start with, like a math module. So I created a Jupyter notebook already, so that you can better understand. So what math module is doing. So if you install, so this is how I created math module, and DAR, if you see, it has a lot of attributes. So starting from cryptography, sorry, not trigonometry and geometry, all kinds of functions are there. So if you ask for help for any module, if you ask help, it will give list of the entire documentation, and then like what functions are there and what constants are there. So first, if you see the basic math constants like pi value or e value, so infinite is there, not a number is there. So when you go for like processing any Python file or sorry a CSV file or anything, we want to check whether the value is a number or not. Sometimes CSV files will have empty low. So in that case, we should treat it as like not a number, right? Maybe you don't want those records, you want to clean them. So all of them we need to specify that. Tau is there. Then coming to the functions. So like there are like built-in functions. Like built-in functions, we have functions here. What are they doing here? So if you can understand, so this is into seal. For any room, if you have seal means in the top, right? Floor means down. For any number, so we call it as an integer if it is overall like so 6, 7, 8, 9 like that. So 9.1 is not a so perfect, right? So it will try to do to the upper bound. After 9, what will get? You will get 10. So at what limit it will do, I will show you. See, if or any number, if I say 9.7, means it is greater than 5, right? So from 5, so you see here, so 9.7 also becomes 10. 9.5 if you give, that also becomes 10. 9.1 also that becomes 10. 9.0000, these many zeros. Then if you go like more than 6 zeros, it generally round offs any floating point value. If you want to preserve the large numbers, especially when you are working on some types of projects, there is a module called as decimal module. If you work on it, even 32 digits also it will preserve. So but by general, so if you give any number which is large, it tries to round off to nearest number. And if I say 9 also, it will give 9. And if I say minus 9.1, that's where you can see, right? It is doing in negative, seal is reversed, right? So it will go to the next highest number. In negative, so minus 8 is less than minus 9, right? So and minus 10 like that. So whereas in positive it is different. So simply to answer, if you go for a number which is more than that, it will give so 10 all the time. So it floor will try to go to the lowest number. So 9.7 becomes 9, 9.5 also, 9.1 also, everything becomes to 9 because that's the lowest. Then there is something called as truncate. Truncate is like your int built-in function. No matter what you give, it will just remove the decimal part, that's it. If it is 9.7, 9, 9.5 also 9, 9.1 also 9, so it doesn't matter, it will just remove. The int built-in function also does the same thing, so for you to get it. So apart from that, if you see, there is something called as round built-in function. Round will round off to the digits. If I say 0.0 till 0.5, it will go to the previous integer. If beyond that, it will go to the next integer. The real world examples are simple, right? When you go to any grocery store, when you have a change, they try to round off. Now the digital payments are happening. Earlier, when so everyone used to pay in cash. So we used to round off, right? Because no one can give like 10p, so 2p, 3p like that they cannot give. So that's why they used to round off, right? So that's what. So this round is a built-in function which is created in Python 3. So in Python 2, it is not there earlier. And similarly, round is very interesting. If you just do round, it will create an integer. But if I say apart from that, one digit if I pass, 0 also, it will create a floating point value. Means round will create both integers and floats. If we just give round, it will create integer. If you pass any number, it will give those many digits. Say this time I did a loop of 0 to 10, and I'm passing that value every time. So each time if I pass, I get one thing. See here, when I pass 0, I got 3.0, Tara 3.1. So like that, you got all the values. So the number of digits you pass, of course, the value has the potential only, you get it, right? So similarly, if I say 12.7 so and so, so max it can go. Even if you give 9 also, it is not going, because you don't have that much big value. So to max it has, it can go. That's it. Similarly, there is something called as the next after. So this is a relatively new function which was created. It will return the next floating point value after x towards y. Means after 2 towards 5, what is the next so floating point value it tries to give. So anything like, so if you say after 2, if I want to go till -5, so what is the next value towards that? Means like you can think like, after 2, 3 will come, 4, like that, right? But it will give like floating point value something between 2 and 5. So like that in random. So similarly here it will give like from 2 towards -5 means what? It should go in the reverse direction. So it will give like 1 point so and so. So, and like if I say 2 to -5, you see? So it is giving, so after 2 towards -1, it is giving the next value. So it means like very small magnitude values it is giving. Similarly, power operation.
Sorry.
Yes, please. Yes, please.
Yeah. I did not understand the -1 and -5 parts. So the value, I understand the upper, the positive value, the first one.
Okay. So -5 means what? You need to go towards 5, right? -5 means what?
Yeah.
So from 2, if you need to go to -5 means what? After 2, 1, then 0, then -1 means reverse direction, right?
Yes.
So that's why it is going to 1.99999 all here, not 2. I think 16 digits. 16 digits precision it is taking.
Oh,
okay. Similarly, here also you are going to toward this direction or that direction, like that. Similarly, power operations we can do. So here there is one more interesting thing. So Python actually evolved over a period of time. By the time Python evolved with all kinds of things, math is module has all the features already. So some of the features were duplicated in both math module and in built-in functions in Python. So earlier Python don't have a symbol for power operation. So then everyone used to use math.power in the way early times I'm telling. Then they introduced the power built-in function. So that's the reason now math.power is also there. Power built-in function is also there. So that's the reason math operations, anytime if you do, it will result in a floating point value. Whereas what are things power built-in function, it will give only if there are any one of them is floating point value, right? Here 2 to the power of 4 is just 16, you got it. Whereas 2.20 to the power of 4 means you got 16.0. So whereas power will every time give a floating point result. Not only this, for anything else. You see now, our built-in power function can take like 3 arguments, right? It can do the power operation on first do and the modulo operation with the last value. Whereas that we cannot do with math.power. Similarly, reminder operation, so which can be done with math.reminder. So you can do like reminder operation. So there is some more thing called as fmod. Reminder and fmod are almost similar. You can just have a look at it. Maybe take it as an assignment to just research. Reminder fmod. You see here, you got the values. So why you are getting every time a tuple? Because I am doing a comma separated 2 values. That's the reason I'm getting 2 values. As they are comma separated, it is showing like a tuple. I just want to show comparison at one shot. That's why it is showing like this. Similarly, absolute, right? You have already worked. If you give any number, if you want to get the positive value only, so that's where you use it. So generally, when you are working on a trade analytics, whether gain or lose, or you want to just know, right? So that's where so you use absolute. So similarly, f absolute means it will result in a floating point value. So absolute works with both integers and floats also. If you give a float, it will give float, else it will be integer. Whereas math.f absolute every time will give a float only. That's what math symbols, math modules mostly it will give like that. And there is one more thing like copy sign. So copy sign means so when I'm working on trade analytics, I use it. So if you want the first value and the sign of the second value, that's where you use it, this one. Means first value is -9, but just it will take 9. But the second value is 2. It won't take 2, but it's sign. So first value is 9 and second value sign is positive. So that's why you got 9 plus 9. Similarly, so if you want the first value and second one sign, -9. First value and second one sign. First value and second one sign. Like that. Similarly, if I say factorial, hope you remember I implemented factorial in different ways. Factorial of 5 means what? 5 into 4 into 3 into 2 into 1, right? You can do with the reduce also, I told. If I do with reduce also, I get the same answer. So hope you remember. So if I do like reduce, so of range of say 1 to 6 if I do, so I get the same answer. I can do like from func tools, import, reduce, and I do like this. It works. So it means a problem can be solved in different ways. How you will learn is like over practice. But I'm telling that these are built-in things. And similarly, some built-in function, but some will give just values, whereas you have some the same thing exactly, but in a floating point result. That's it. Similarly, you have GCD function, which I need not tell what is GCD. GCD LCM is there. So they introduced LCM also. If you give some numbers, the least common multiple among all of them you can pass. And similarly, square root you have. And recently they introduced cube root also. So cube root also we can get. And similarly, if I say mod f, so mod f means any number you give, so it will divide to two parts, the fraction and the remaining integer. Means let's say 1.5. 1.5 means after, like if I take 1 as an integer, 2 as an integer, 3 as an integer, like that. After 1, how much is there extra? 0.5. So that's why 0.5 comes. And here also you get 1 as a 1.0. Because it every time gives a floating point results, it gave like the extra is 0.5 and 1. And similarly, if I give minus 12.7, so what is the extra? This one, right? It will give the extra like this. So to be precise, it's 16 digits precision. And what is the previous thing? Minus 12. You got minus 12. Similarly, mod f you gave like just 32. So integer you gave, but still it gives like extra is 0. So 32.0. So sometimes if you need that, you can go with that. And similarly, exponential operations. So you can do with math.e to the power of 10, right? Similarly, like exponential, also we have different ways of doing. And similarly, modulo also. So mod means, log means what? So base e, right? So similarly, base 10. So base 1p. So base 2. So if you are aware of, you can use these mathematical logarithmic operations. And similarly, trigonometric operations also we can do. So means we can, if you have degrees, we can create radians. And if you have radians, we can create degrees also. And right? So sine 90 and sine 90 degrees. Sine 90 degrees means, so radians means what? You get 1, right? Sine 90. So degrees radians. So similarly, just 90. So as a number, you get like some value. So that's why 90 degrees I did it. Similarly, so cos 90. So like tan 90. So so inverse cosine, inverse sine. So hyperbolic. All these functions you can do. And also hypotenuse. So this is like Euclidean distance. If you are aware of hypotenuse, means Euclidean distance. Means with respect to the origin, how much distance this number is. So these are all mathematical functions. If you know a bit of math, you can understand them. And similarly, so I told, right, whenever you're getting some values from a CSV file, so when you're processing, you want to check whether it is a really number or not. So the field is empty or not. All those things you want to check. So when you want to check the validity, these are very much useful. Next you will learn is a pandas module where you will tell, I'll tell all. And if some number is finite or infinite, that I can check here. And similarly, if you are aware of gamma functions, we can do logarithmic gamma. So error functions we can do. So similarly, so new functions are slowly getting added over a period of time for this math module. So this is all about this math module. So you can just walk through. I have added like one more PDF for you to better understand, which was like created way back, but still a lot of things are valid here. But so there are other things also. You can also work with like different kinds of math. After the math, to understand, there is one more thing called the sys module. Sys is a module where you can understand a lot amount of things about this Python as a language, how it was evolved. Hope you remember. So most of the things you have dealt till now were indirectly you are using sys module only. So let me open a new thing like sys.ipynb. If I open, okay. Okay, sys module. So any module, how you use, first you import the module. So then like you ask the help. Help is a built-in function. If you ask, it will give the entire documentation of what all things are there, what is the description, so and what are the built-in functions. As document is very big, it is saying that as it is very big, I'm not showing you. So you can go to here, you can see. Means it's giving like a big list to you for you to just see. So you see here how many built-in functions are there, how many attributes are there. It's a very, very big thing. Static objects means every time these values will not change. Once your Python's Python was installed, these will be created, and every time afterwards it will be the same. So like what are the built-in module names? Once you Python installed, so what are installed, those are built-in modules, right? Like that copyright, execution location, so where it is, so what is the max floating point values, max size, platform. So don't you think that these won't change? That's why they are called as static objects. And functions to give anything for you. Hope you remember we already did few of them, like exception hook when you're working with exceptions, or like we have worked on debug hooks. So like the different hooks I worked, right? Display hooks, exception hooks, and all these things. And similarly, different functions are there. What all things it can do. So reference code, get reference code. So some of them we have already worked on. And there were some constants also. And if you want to know the list of attributes, there is something called as DAIR. If I do DAR, say a DAR of sys, you get what? All the list of attributes it has. Again, it has again a big list of attributes. If I go, you can understand. Even if I do remove the things which are underscores on the other side, still I have a lot of things. But do you think everything is needed? No. So you will discuss the most common things, but others we can discuss. So when you are going in real time, say like, so the most common things, sys.win version, sys.version. This is very interesting. So every time who comes to Python, they kind of confuse us. Win version. Sir, do you mean that there will be a Mac version or Linux version? No. Somehow they created this variable. So I don't know why they created. It is a bit confusing. But every others will tell clearly. So get Windows version will give the exact Windows version. I'm using Windows 10. So which is this binary. So platform to something service back. This is the Windows version. But Win version or version both will give the same thing. So Win version gives 3.11. So it is giving precisely the tags when it was created, when I installed and everything, right? So the latest patch when I installed everything. And similarly, so get Windows version, you understood. So sys.implementation, this is the most important thing. Now I will tell a story to you. So Python, how you are using right now, you are just executing every time Python. But how it works in the backend is that your Python code first will convert to some base language. So we are using the C Python, means your code is converted to C language, and from that C language it goes to the machine. That's why Python is a bit slow compared to the C language or Java or anything. We don't have a compiler on our own. We rely on another compiler to execute the things. So this is the C Python. Sir, what are the other implementations? Means like Jython, which was converting from Python to Java and doing it. Then Ironthon, which converts from Python to .NET and does it. So like that we have. And similarly, API version, it is nothing to do with us. It is the implementation, means the people who create Python is that right? So they release versions and others. So E is finalizing. So all these things you have. So, and this is the copyright information. Every time you go to interactive mode, don't you think you get the copyright information? Yeah. So this copyright information was changed over a period of time. So initially when Python first was created, it was with this license. So then like it was like this, then bopen.com. From 2001 onwards, things changed a lot. So Python Software Foundation was created and you're working. So this is all about it. So then the next set of examples, if you see, like this, if you see, what is the max size and all these things. In fact, this is the maximum size of any number that we can store. But let me take a number. So what it's saying, this is the maximum size of any number that we can store. But if I take anything more than that, it should throw an error, right? That's what you expect. So did you see? It didn't throw any error. It took it. Means earlier there used to be this limit called as sys.max size. Now it is no more there. So what the change that it is that now the maximum number that can be stored depending upon your RAM. So just imagine your system has like two kinds of memories, right? Read-only RAM means so where you store the memory in runtime and work. So ROM means where you have your so firmware and others, and you have hard disk. So though you have like 500 GB or 2000 GB also, you cannot store in hard disk and use it. In runtime and processing, we need to have a RAM only. Everyone's RAM is limited, so that's why based upon your RAM you can have it. If let's say I have a 8 GB RAM, within this 8 GB RAM, I will have like private heaps for each of the program. So on my system, many things are working right now. The Zoom is working, Python is working, VS Code is working. For everything, there will be separate memory spaces. Those are called as private heaps. So if my RAM is big enough, my heap size will be big enough. So I can store a large number. So if my RAM is less, I can store a less number. That is a simple conclusion. And coming to the byte or max Unicode, this is very interesting. So you cannot have a value which is beyond that. If you are aware of Unicodes, I told something called as ORD and CHR. You remember? If you give any character, if you want to get the number, it is so ORD. Similarly, if you give a character, if you want the number, this is. But if I try to get any number which is the size of this max size, so max size, if I give, I get the value. But if I go beyond that and ask, beyond that, it will throw an error. So still this limit is working. Means if you ask any value beyond this max size, so max Unicode, it will throw an error. Similarly, coming to the next one, which is the byte order. Byte order means in which how the memory is stored. So earlier there used to be a conflict between two kinds of software versions. IBM used to create one way, all other companies used to create one way, like that. So in the way in which the bits are stored in the memory, which is very least interested for you, but simply I'm saying, you remember this byte order, right? 8421, all this series, when you're converting to binary form. Generally, you store in this order only, right? This is a little endian. Big endian is another thing, where this upper byte will go in the other side, right side, and do it reverse direction. So that is not needed for us. Just to be aware, this is what it works and how. And there is one more thing called as like a hash built-in function. So here, if you see, so I told everything to you. So DLL handler means Python scripts also use a DLL called as PyDL. If you see some scripts called as .pydl. And similarly, what is a floating point representation? So next, hash version. There is one more built-in function called as hash. So hash is a built-in function. Though you don't use, same like bull, this function also you don't use it. But in the backend, it will be doing. For any object, if let's say if you are trying to store in a set. So if let's say I'm trying to store in a set some values. Say like if I'm going to 1, 2, 3, 4. If I do, I'll get it. Whereas in the same set, in the above, if I add one of them as like a string or something, so sorry, list, then it will say like, it will throw an error, right, for me. If I say like 4, 5, if I do, it will say like unhashable type list. Means if you do hash for above like integers you did, it worked. But if you do the same for a floating as a string, it won't do. Sorry, list it won't do. So why it is needed? So when you want to store in a set, or when you want to store like a dictionary key, things should be hashable. So means only when you get a unique value you can do. So that is where this built-in function called as this is help. And in the last leg of the sys module, so we have these many things. So executable. If you remember, anytime when your system is created, you have something called as executable and its version. So in my system, Python was installed in this location, and its prefix means where it is located. Similarly, so there is two types of executable and prefixes. And similarly, prefix, base prefix, and executable like that. So in this case, you can see all were same. But next, when you are creating a virtual environment, I will tell that there are two types of things. So on your system, you can have one version. But if you are working on multiple projects, let's say in one program, one project you want to work with 3.11, another 3.10, or both 3.11 only, but different versions of software. Then you need this kind of virtual environment. Then I will tell what is the difference. But what you understand is like where your Python is located, that point it will show. And next, one more thing called is don't create bytecode. That I will tell afterwards. Whenever you're working on user-defined modules, you will understand. Then so you will understand about the default encoding, which is like ASCII in Python 2, whereas UTF-8 in Python 3. That's why you can process even a non-English character simply, right? You need not write any extra stuff. So earlier in Python 2, that used to be a big pain point. Then so you told about, so what is the system encoding errors? So get profile, so switch interval. Switch interval means like, so it is something to do with the, so that is called memory management. So it is an internal point. Then so what are the flags? Hope you remember this one we discussed. So get recursion limit and set recursion limit. So when you go with recursion limit, when you go for recursions, I told that. So this is what you understood. Similarly, for you to understand sys.getSizeOf. Hope you remember this one I told multiple times. Sys.getSizeOf means what? It will give the size of any object. For any object, you can get the size in two ways. Either you keep using the underscore size of or sys.getSizeOf. Underscore size of and sys.getSizeOf will be the same, right? Did you see? For integers and floats and string, all these things, it is same because they won't change. Whereas if I go for mutable objects like a list, set, and dictionary, iterables, if I go for iterables, then things changes. Sir, why this sizes are same both in this direction? Because when your Python code is there, when it is connected to C language, it will store in the same size as it is. Whereas C language don't have a list. They don't have a tuple, right? Means they need to convert, which doing for that, they need to do some kind of overhead. So that's the reason getSizeOf will give the true implementation size. Apart from your main code, it will do the extra thing. That's the reason sys.getSizeOf and the getSizeOf things will be different for iterable objects. This is what you understood. So then one more thing to focus on is about the there are things called as error streams and streams. Means there are three things like this. So std error, std in, std out. This is something not new to Python. Every language have these three streams. Then when you're going for logging, you will understand this. So standard output. So when you're getting anything, when your print is also doing something, right? So what our print statement is also doing, also in the backend, it also using the same thing. This.stdout.write, if you do, you get the output like this. So did you see that whether you do that or print statement, both are giving the same result? So whatever you are seeing in the output, so you can do like this. Similarly, if the same thing, if I do say, I remove this one, instead of std out, if I say std error, you do, you get an output. The same thing you are getting. So it is giving like this. So generally error, you don't use it by default. So, but like when you will see the std error means, the real world example is, so if I do a raise error, so when I'm doing any exception, so how the output is coming, that is a std error which will be used in the backend. And similarly, so this std in is similar to what you do in the input. You need not do these implementations, but you be aware that these are all the things it can do. And similarly, the last things in the std is that about the audit, so display hooks. I hope you remember I told there are few more things, but still we don't deal. And there is something called as built-in functions, built-in module names. Every day I'm using a new module, right? How I'm knowing all these modules means, the moment you install Python, you will get all these modules. You see, zlib, so winz, time, sysmodule, nt, marshall, all these things are built-in modules, right? So you can use that. Like math, there is something called a cmath. So gc for garbage collector, Iterators, so marshall, all these things are modules we have. We can use, so when you're going there. And next, so coming to the platform. So there is something called as a platform. So sys.platform, if I say, it will tell what is a platform. So it is saying Win32. So it is like a 64-bit machine. Still, every time it says Win32 only for Windows. Sometimes we will have some kind of operations. Based upon the operating system, we want to do some commands. Then we can do a commands like this. You see, if condition I did, if the syst platform is Win32, it will do like this. So generally, when I create a log folders and others, in Windows, I want to create in one directory. So whereas in Linux, I want to do in another place. So for that, I use it. Similarly, if you want to deal more with the platform, there is one more module called as platform. So with platform also, you can get like what is the architecture, what is the machine, all these informations you can get from that. You see, 64-bit machine, Windows, what all things we can do. So what is a Python version? What is the implementation? So what is a uname? So all these things we can get from this example. So this is our, so you have. So, and the next last set in this is about sys module. Can do, we can go with the last part, which is like sys.argv. So for that, we need to rejoin again. So now we will go for sys.argv. To understand that, let me create a ordinary Python script .py file. So import sys, and I will ask what is sys.argv. This is one unique attribute. So let's see how it works. To work with it, I need to go to this directory. Clear the screen. Python, so b so and so. If I execute, it will print sys.argv. What are the arguments are there? You will see that. What is this doing? We will understand now. So if I do sys.argv, I'm getting this thing. Maybe like, I can write a f of to better understand what I'm getting. You can see, okay, if I use a CLS and Python, clear the screen, simply Python b so and so, I got the answer. Now there is one more thing in terms of metadata. I say everything in this has a metadata, like even a Python script also has a metadata. So one of them is like __ file __. What is this __ file __? Let me do that. If I ask what is this, so both will do the same job but slightly different. Did you see now? For you to better understand, now see here. You see now, when I did the sys.argv, I just got the file name. What is this? My file name is b _sys.argv. When I did a file, did you get the entire path? Fine. Now let me do the same thing again. How can I execute this file? Any Python script you can do execute in two ways. Either you give the entire path, or you give the relative path, or complete, just go to the directory and do, right? So there are two ways of doing. So if I go for the next thing, if I copy the entire path and give here Python space entire path, that's the reason I told not to have any white spaces in folder names, else you need to place a quotes again, that is a trouble. So now you see entire path I give. When I give entire path, sys.argv and file name both are same, right? So okay, not only this, I can also execute the same file. I will go to one directory level above, and I have like 03 system. Then within that I have executed. So indirectly like this also I can execute. Similarly, Python space 0, I go with two directory levels above, 08. Yeah, two directory levels above I go, and then I do like this. Like this also I can execute. And if I go for another three directory levels above, as in I'm in a Windows, I'm doing these paths. I'm going to 3 levels above, and I'm saying like Python for data engineering /08 03 and v/v so. So did you see I can execute the same Python program in these many ways? Now did you understand any clarity about why I'm doing like this? So did you get any thoughts of what could be the reason for that? The reason is very simple. So file will give the entire file path every time, whereas sys.argv will give you, so what are the way you have called the program. The Python program, when you're executing, whether you're giving relative path or entire path, whatever the way you have asked the Python script called, it will give that path. Means that is more of dealing with that. Now going further, so what else we can do with this? So this is one of the advantage. If I go like Python space again the file name, just I am giving this path. Apart from path, till now you didn't give anything, right? So this time I give like some garbage, something I give, some numbers I give, something I give. In this case, did you observe? File is again giving the same thing, whereas sys.argv, did you see that it is doing what you needed? So maybe like this time I can comment the underscore file. So as it is not needed. I'm just focusing here. Did you understand? So file will every time give the file name, that's it. Whereas sys.argv, apart from your file name, it is giving all the arguments. So this is what we will exploit to use it. So what is the purpose of it? I will explain in one shot in the next program. Hope you understood, right? What is the sys.argv doing? What is the command line arguments and so on. So based upon these things, so I can create a small program which can do this. Let me go for the real world example, which is like a lottery ticket .py. So I'm creating a .py file which is doing this lottery tickets. When I'm doing in a lottery ticket game, same like winning guess name. So I have a lottery ticket name. So first you create a program. So user win Python 3, which is the shebang line script. Then you write the purpose lottery ticket, so game, you create it. So then like first we need to import the sys. What is the purpose? I'll tell shortly. So any program, when you're working with modules, the module should be first, then constants, then the other things. So constants means like, let's say I have a winning ticket. So which is a constant, right? Every time the same number will be the same. So maybe like I took, so it will be like something big number, right? It will have like some digits also. Something they will do something, some big number for you to better understand. I wrote it. something like this, big number. Okay, then after that what I do, so I need to do with whatever I'm getting, print of, sys dot argv. So what my intention is like, the user when they are checking, so they will check along with the number, they will give the ticket number. So C underscore lottery ticket, and after that they will give their lottery ticket number. This is what my expectation. If when the user gives, I want to check whether it is a lottery ticket number or not. Means like, so as it is giving a list of 2 numbers, so I can assign to something, right? Can I assign like this? So when user is giving, user ticket is something, and if I execute, I get user ticket. So if I print what is the user ticket, I can do it. F of user ticket equal to, if I do, I get that answer. What is the user ticket? Is it clear now? So I'm not bothered at the file name. So every time when user gives, say Python space, so C so and so, and after that they give some number, I want to check whether this number is correct or not. So very simple, the logic. How do you implement? So if user ticket number is equal to winning ticket number, that's it. So you printed, so you won the lottery. So that's it. So else, try again. It is not like a number guessing game. We cannot say like increase your guess or decreasing your guess, because like, so it can be alphanumeric also. Sometimes they make it like alphanumeric like that also, right? To make it something complicated. So you just take it, what our user gives. If that is correct, you give the answer, else you say sorry. Though this is good, but what if this time user don't know and gave like just a program? So don't you think it is throwing an error? So means like user don't know, like they need to pass extra values. So then like what you can do, you can do a try block and pass on these things. And if the user has done anything issue, then you do an except. Mainly for index error, you can print it. Hey, you did an error, bro. And in else case, means if everything is good, that's where you do, right? So don't you think this is how you do? So in this case, what will happen this time? If I execute again, user gives nothing, so you get index error, right? So means when index is error is coming, you can tell like a print help also. So my so like you can say usage. So you need to pass like, so Python space the file name .py, and after that you need to pass the lottery, your ticket number. Okay, this is how you need to tell. Then see, this time when you're using, it is saying list index error and doing it. Index error every time, so it comes in this position. Maybe you are not interested in index error, just you want to print the usage if the user is not doing. Then next time onwards, so maybe like instead of just file name, you can give your file name also, right? So like that you can give. So now when you're asking every time, the usage will come. This time user will execute like this. Whatever he executes, it comes. It is not correct, so it is saying try again. Now you give some other number, something else, it will execute. Maybe you give the exact thing what is needed, say Python space C so and so, then you give, it says you won the lottery. Is it clear? But you need to do like this. So this is method 1, where you are expecting the user to pass 1. So that's how you used it. So maybe you can do the things in much better way using another way also. So instead of checking, and if you don't find, you are not doing right, rather you also can check for the length. That is much more easy, because by default sys.argv will have one value anytime when you execute. So you are expecting one more value, means totally user should pass 2 values. Means instead of doing all these things, you can simply say like, if length of sys.argv so is not equal to 0, means if user passes extra also, you don't want to process, then you can do like this. So please enter the number also. You can pass, or simply you can give the entire usage, whatever you wrote in the top. So like that, you can write that statement also if needed. So else, if everything is good, then you want to process. So then you want to process. You see, the same example you did in two ways. It's up to you how you want to solve. Fine. So if I just execute the C, did you see in both the cases, it didn't block the code and it gave me clearly. But apart from that, if I pass, so if I give any other number, it will check and evaluate. If I give the exact number, you can say Python space C so and so. This. Now you understood the lottery ticket number. How do you create your own things and others? So with this example, we will now move to the next module called as argparse. So let's see why that particular thing came, why people are going with this argparse, and what we will do. Argparse. Argparse, maybe like I can take this as, okay. I will give you only one example. Argparse. Earlier there used to be something called as optparse. Now we have something called as argparse. So how do you write a program? First the shebang line, then the purpose of it, then how to use it. Let's say I have one small problem. I have like username, password, and server name if you are given. I need to just print it. Because in real time, what happens when you give username, password, and server name, the scripts will execute on that particular service. That is what real production happens. As you don't know how to connect to your server and all these things at this stage, I just take like printing them. So how do you take? Let's say I have three values, I want to print them. So my logic is like this. If I was given any input, I want to print. So for that, I need to have username, password, and server. Then how do you get the username, password, and server? The first way is like hard coding. In the server itself, you can do a hard coding. You can write a program. So and like hard code means then if you do hard coding, I need to navigate back to the directory. Okay. So Python space a so and so. What are the values I gave? It will print it. So I'm just doing a simple job so that you can understand the concept me. So next, but do you think like writing this hard coding is a good thing? Because if you create a production project, so every time in the production thing you go and edit the program means sometimes accidentally you change something else, then it will be a lot of issue, right? Then what is a good way? So okay, then the best way is like instead of going like this, we can instead of hard coding, we can do runtime. So in runtime, how to get? Using the input built-in function. Using input built-in function, also you can get it. How do you do? Along with that, you just run it. And if you pass like username, say like, Uday, something. And if I do some password, so then like if I have server name, I do some server name, say like, so photos.google.com, something I have server name. I give these three values. So then what happened? This is a problem we solved. Instead of hard coding, giving in runtime is good, right? Fine. But here one more problem is there. The password that you are entering is having an issue. So username when you entered is fine, but password if you are entering and someone is seeing in the back, it is not good, right? So then how to solve that problem? So for that, one more extra thing. So there is one more thing called as like this. Instead of a password like this, the third option I have to be, I would take. So instead of like these three. So for password only, I can use a module called as so getpass. Import getpass. They created one module called as getpass. So instead of input, I can do like getpass dot getpass. If I do right now, execute the same thing again, Python space a so and so. If I execute, again I give the username, some Uday something. Then password, I give something. I give big password, but you can't see what I'm typing. Then I give the server name. So photos.google.com. You see now, did you see what are I typed in the password when I'm typing? No, but you got it right. But this is good. But this problem is good enough. But still, one problem is that what if a program is executing for say 9 hours? Will you wait for all the 9 hours to execute this input? Sometimes at the end, sometimes in middle you want to run. It is very difficult. Assume that you are ready to run all the 9 hours you want to sit before the system and do. What if your program should run in the morning 9 o'clock or morning 2 o'clock or midnight 12 o'clock? Then you can't do all these things, right? Then in that case, what is the solution? So the solution in that case you have is, this is the 3. The third case, next one is like argparse. So, and like sys.v. So what are these doing actually? I'll tell you. So let me go with the sys dot. This is 2 here, right? Okay, 2b. And this is a sys.argv. What is this sys.argv doing? How it can help us? Hey, don't give the values in runtime. So because runtime giving is good enough, but you cannot wait all the time as needed. Then the solution for you is like getting the values in runtime. How to get the values in runtime? So you know sys.argv, right? If I print like sys.argv, it will print all the attributes you have. So what are the attributes you have? It will print it. So maybe like you can write a condition, same like what you have learned earlier. So, and you can do, means like, you see, so you want 3 arguments, means username, password, and server name. So this thing, apart from your main code, so totally 4 arguments should be there. That's why if it is not equal to 4, then you are saying like this. Then it will sys.exit, I am saying, means exit the code. It will not go to the next line. If you do any time less than that, it will print this help and it will stop. Then if you see Python space, so a so and so, if I just execute, as this condition is not met, it will go inside, right? It will tell the entire help, here run this program. Or else if you give everything clearly, how we can give Python space example, and like I give the username here itself when I'm passing, and password also here itself. Then like server name. No, what are this a server name? So maybe like so photos dot google.com. I gave these 3 values and I got the output, right? Now when I'm running itself, I give these inputs. But so it can execute for 10 hours or 10 minutes, it's up to you. The program can execute at any time times or any time. So when you are running a program itself, you are giving, right? So you need not worry about you changing the interlayer logic. So to optimize this better, instead of getting 3 values and assigning 3 times, you can also do unpacking, right? As I told you, unpacking. So unpacking means what? So doing 3 values at a time and getting the answers. If I do the same thing also, you can get the same answer. Now, so but help is like something very weird. It will tell like, you day username, password, and server name. What do you mean by username? What is password? And what is the thing? This is good enough. But one more problem with this sys.argv is that it will take for 3 arguments. That's it. But what if you give these 3 arguments in a different way? Means assume that you gave the same arguments, but in a slightly different way. Means I thought like I gave, and first I gave the server name. I thought like, photos.google.com. So as the first means like server name, then I gave the username and password. Then what will happen? So as of now, I am showing this example as printing for easy to understand. Just imagine if the wrong values go to the username and password, it will fail and it will create an issue, right? So the problem with sys.argv is that it will check for 3 values or 2 values or anything, but you cannot specify that which one should come first, which one should come next. That all we cannot do. So then what is the solution for that kind of problem? To address that, we need to go for argparse. What is this argparse and how it can help us? So the same problem we can solve in a better way using this. So, okay, this also I'll comment. So what is this argparse doing? For a moment, so I will tell you, argparse means first we need to create a parser object and then we need to work on it. So there are 2 things here. description and epilogue. I will tell you what is this. For creating a documentation, there are two things are there. What is this doing? I will tell you shortly. Like, so if I want to get the arguments I need to add, there are like two ways. Hope you know in Linux we do some commands, right? ls, so ls hyphen la. So all these commands, how they work? If I say ls hyphen l, so ls hyphen la. So how these commands are working? So in the same way to create, we have these things. So I did a parser. Either you do -u or __ user, and I give a help for this argument, and I'm telling what data type I need to take it as. User gives something, but convert to a string. Is it mandatory or not? All those things I can tell. Similarly, I can ask for one more parser. Say, you can use -p or __ so password, and there is a help type required or not. And similarly, you can also give the username password, right? And we have server name. I can give the third argument. You can pass like -s or -- server name. Then you give the help related to that argument, type required or not. If I say required equal to false, then I can say default value. Means if I write default itself, the same thing. So like that it can happen. So like this, you created these three arguments. Then how do you get the values? We need to create the parser. All are going to this parser object. Then you can get the values from it. It is slightly different initially, but slowly you will understand. First, you create a parser object. For the parser object, you add all the arguments, and from that you get the collective result, and you assign to your variables your usage. Now, if I execute same Python script, so what is that? Example, right? I execute it. Now, did I write any help? No, but it created a help on its own. So by default, it only is giving the usage. That -h is optional, but like all others are mandatory. Did you see in this is a Linux format. If anything is coming in square braces, it's optional. I wrote for server, it is optional, right? Default is false. So required is false. That's why it showed like this. For H also like that. Means if I say Python script -h. Now, did you understand? Whatever I wrote, the entire documentation is coming. I didn't create this entire documentation. It created on its own in the backend. Whenever you want to create a command line tools, we need to use it. See, what are the description you wrote? It came in the starting. Whatever the epilogue you wrote, that came in the ending, right? So when you're creating argument, you passed both of them, but both are not mandatory. Whenever you want to create your own, UI based tools, you can use it. So, and like for these options, it is saying either you can do small or full. This means, so instead of help, I can do like --help. Like this also I can do. So if I do like -h help or like big one, so both will work in the same way. So if I give like this or like this, both will give the same answer. Hope you're understanding. Similarly, now we understood about these two arguments. So what about the other arguments? If I say -u and I give the username, the username is like, so the 3 Prakash I wrote. So, and like password, I have like some garbage. So then like I have a server name. So for that also I gave yes, right? You see, -u, -p, -s I gave. So -server name, same photos.google.com. If I give, I get the answers. In the same lines, I can give a long versions also. Means one of them I want to change big, or like for all big also, it's up to us. -- server name. If I do, you got the answer. And so two of them also I can change. So -- password, I get it. And I can change everything also like capitals. So like 2 hyphens, username, right? Here I wrote username. Exactly we need to write username. You see? And the beauty of it is that we can change the order. Means the problem with the, argparse is that you check for 3 values, but you don't know which one should come first, which one should come next. If the user gives them in a reverse order or any other order, you cannot recognize. Whereas Using this, if I give, if the user gives in any other order, see here, I gave like 1 hyphen, so I need to give 2 hyphens. Then it works. To make it in a short form, so these things, right, you have. So let me take this one, or like in the password also I can give in the starting, and one of them. And the beauty is that, so if you don't give the optional values, it will take on its own. So if I don't give username and password, it will throw, because password is mandatory. If I say password is equal to something, then server name, if you don't give, you wrote a default, so the default will come google.com. So don't you think that you can write a better programs here? So now a small example that you can try on your own, which is for a calculator. You create your own example so that you will understand more. You create a calculator example, so where you can do all these things. I wrote the logic, just you need to make you understand like how things works. I wrote like 3 functions: addition, subtraction, multiplication. I wrote like some help also, how to get it, some description, and like 3 arguments I passed. So then like I'm taking them and I'm doing the addition, subtraction, so and so. Means when user need to execute, just they need to pass Python space b so and so. If the user is not passing the arguments, then what are the help is there, it will come. So what are the mandatory are there? So for these 3, there is no mandatory. If you don't give also, there are defaults. See here, for all these 3. So that's why execution happened and you got the results. But if you give any argument, say like, hyphen hyphen number 1 is like 100, the other 2 will be defaults and execute. Sorry, I need to be a single hyphen. You see, I didn't define twice. So lower format and upper format I didn't give, only one format I gave. So that's why I should give in exact way. So in the definition itself, if I give 2 hyphens, you need to give 2 hyphens. So like that, we need to define. Hope it's clear. So like this, you need to parse anything you can store, so and do it. Number of arguments, you can tell that, and how it works. And in the same lines, there is a one more thing, like so OS module. So coming to the last thing is about the OS module. So if you know OS module, you will understand the entire program, Python programming clearly. Because in OS module, if I go for like IPython notebook, then I can tell a lot of things. You see, so in okay, selecting the kernel and like import OS. If I see, if I do like a DAR of OS, just a DAR, you can see how many attributes are there. So there are like, very huge. If I see, these are like flags. These are starting with capitals, right? All capitals. These are flags. Then underscores if I remove. Still, I have a lot of attributes. And some of them were deprecated. And some of them will not work in all operating systems. So some attributes work only in Windows. Some works in Mac. Some work in Linux, like that. I can say like Python achieved the platform independency because of this module only. A lot of things are there here to help us. Earlier I showed sys.platform. Based upon the operating system, we want to execute something, we can use Iterators, right? So like that we can do here also. So here if you see, so help of OS, you can see help will give the entire documentation of what all things we can do with it. And so the entire source code. You can see the path names, C names, and all these things, how the things are working here. And typically, if you go for the help module, at the very basic, it can do the file operations, it can do the cleansing, it can do the system commands, and all these things. For you to better understand, a simple examples I can start with is in terms of usage. With OS module, you see here, you can take the path informations, like what is the current directory, what is the files, and all this information. So if I start with, os dot current directory. Means generally when you are doing like cd commands we do, right? So if I say like cd dot, so it will go in the current directory only. If I say ls dot means in the current directory what are the files to show. So similarly, like current directory, os dot say get current working directory. So there is in Windows there is no command. I don't remember, but like in Linux there is something called as pwd. If you give, it will give the command, right? So based upon that it will give. Similarly, os dot list dir. So if you want to list the files, you have ls in Linux. In Windows you have dir. So instead of doing both, if I do os.listdir, based upon the operating system, it will go and get the values. So in without directory, see, I think I am in the other directory. I need to go to the OS directory. Now if I execute, say pwd, I get it. ls means I get it. Only one file is there in this directory at this moment. So I should get it. And similarly, if I do dir also, I get it. In both the cases, I got only one file. os.list directory gave, right? So similarly, if I want to change a directory, how do you do? If you want to go to the previous directory, so it means you do two dots, right? To understand parent directory, os.par dir if I do, I will get the parent directory means two dots. See here. So if I want to change directory, so os dot so chdir means how you do cd, there is chdir, and you can pass like so os dot par dir, or so you can also do like os dot chdr of two dots. So in both the ways you can do. After changing, if I say os dot get current working directory, if I say, it will say it is a parent directory. See here. If I do this thing, now if I say, hey, what is the get parent directory? It has gone one level above. And similarly, if I do like os dot two levels above, if I want to do, I can do one shot, right? Similarly, I can say os dot chdr of. So I gave like this. And observe there is a path. So of course, in Windows nowadays it's working both the paths. So if you want to create this path also, I will tell shortly. So I have gone two levels above. After that, if I ask, hey, what is the current working directory? It will say data engineering stage. So similarly, if I say here also, os dot get current working directory, see, it is the same thing, right? Now, if I say os dot get current working directory, I get it. So similarly, if I say like, so ls or dir, you get the things. So means os dot list dir, sorry, I did. So list dir. List dir means directories and files both. It doesn't mean that only directories. Did you see in this level, there were only folders. In the above level, there are only 3 folders. That's why you got it. But if I go one level down again here, you see one level down, I want to go into it. So if you want to go to parent directory, you do dots. But if you want to go inside, you should say cd. So Python for engineering. This is how you need to do. If I do, I go to it. Similarly, if I want to go to this directory, I should tell like, so os dot chdr of, as this is a child, I need to give like this. Now I go into it. So I am clearing the screen. If you want to clear the screen, cls you do, right? Or in Windows, you have like clear. Clear is another command in Windows. So whereas if you want to do the same thing, so but like here there is nothing to display. So but like in system, if you want to do os.system, you will do. So any Windows or Linux command you want to execute, you can do it. Or like if you want to do based upon the platform, you can do it. Say import import sys, and based upon sys you want to do sys. So if sys.platform is equal to, so win32, right? Win32, then do os.system. Any command. So see, command line, if you want to do anything, you can do like this. So if I do os.system of, so clear is the Windows command. So in all other Linuxes, so POSIX versions, we can work with so cls. So if I do like this, based upon the operating system, it will do. In not here, right? In the script, we can do that. So, but just I'm showing. So coming back. So here, if I do ls, I will get the list of folders in this directory. Similarly, if I say os.listdir, in this directory, I can get it. So without going to some directory, I can just check in a different directory. Means ls, within these files, if I want to check how many files are and folders are there in 08 modules, I'm not going to the directory. So in the same way, os dot, so list dir, it is by default option. If you don't give, it will give the current directory. But if you give anything, so it will check in that module and give it. Did you see in that directory how many files are there? You got it. So not only that, so if you want to go to ls dot so and so, within that I want to check in the 04 OS module. I want to check how many files are there. Similarly, I can do like same thing, os dot list dir of 08 files slash 04 modules. I can get it. But sir, this is a Linux path. In Windows, this slashes should be in the other side, right? We need to have the slashes in the other side. If I do like this, what will happen? It will throw an error. This is what you need to be aware of. Generally in Windows, the slashes, it will come like this. But generally this is treated, we will make it simple. You see, the problem is very simple. You cannot go to this thing here. The reason is that in Windows, the slash is there. After slash, if you have a number, it will treat like a Unicode. So that's the problem. So you need to treat like a uniquely. So that's why we should say like slash. If you write like 2 slashes, then it will escape that slash and you get it. That's why whenever you're printing any Windows paths, it will show like this. So that's the reason. Either you can go like that. Like when you're writing, it would be difficult, right? If there are 10 paths, every time you cannot write slash slash slash. That's why in the starting, if you place like a R, it is like a raw representation string. So in that way, you get it, whatever you want. So that's the reason when we are giving, we give like this. When you are getting that, it will be other way. Say like, so you have like import sys. Say like, so print of sys dot. We have what? Sys dot prefix, right? If you see prefix, you get the entire path like this. So what are the path you have, like it, you get it, right? So base prefix or prefix something. Similarly, if I do like a print of this sys dot prefix, because when you're using in a script mode, you don't have this advantage. As we are in an interactive mode, you can see all of them clearly. Did you see the slash is coming in one slash? Here it is coming like 2 slashes, right? Like that. So any paths, when print is coming, it is doing extra stuff such that you are not seeing anything. But coming to back, so list dir of any subdirectory or so and so also, you can check like this. So now we understood how to create it, all these things, fine, right? Now, I want to check again back like os dot get current working directory, where I am. I am somewhere. Now I need to go, so all the way from that place to my directory. So pwd means I have it. I need to go all the way from this to it. So os dot, so chdr of, in this I want to go to which one? So modules. In the modules, I want to go to OS module. So this is what I want to go. OS dot list dir. You see, I have it. Now, in this directory, I have nothing, right? So if you see in the path also, you can see under the OS module, there is nothing. Now you want to add some things. OS dot mkdir means to create a directory. So my directory name is like, so folder 1. You know, these names of folder or directory are in Windows and Linux. In Linux, we call folders and files. In Windows, they call it a directory. That's how the DAR concept came under this. But nowadays, everything can be interchangeable. So we can do like mkdir, so folder 1, right? So say if I create like this or like this, both are same. So in Linux or Windows, I think mkdir is the same command. So if I create using this, it will create a directory. Did you see? Similarly, you here, I want to create like mkdir folder 2, say. In the both ways I want to create. See, it is creating somewhere else outside. So it should not create there, because like there we didn't change the directory. You see? So here we change it, right? Like that here also we need to change. Say 04 so and so. If I say ls, I got the files. So what are the files are there? Folders are there? Both will come. If you want to list detailedly with ls, what are they and their purpose? You can say that -l. -l will give right now. So is it a directory or a file? The D will be there in the starting. So for folder it is saying. Now here in terminal also you can create. Say folder 2. Now in this case, if you see, there are 2 directories now. So here also you can see 2 directories. So how you have created directory? Similarly, what if you want to create multiple directories? os dot make drs. Make drs is very interesting. So make drs means with this also we can create a folder. Say like folder 3 I want to create. Okay. So what before going there, I will tell what is the problem with mkdir. With mkdir, so you can create only one directory. As we have already created the folder 1, if I try to create again, it will throw an error. Hey, this folder is already present. Means we need to check whether this folder is already present or not, and only then we can create. So generally that is what is needed. So if you want to check whether a particular thing is present or not, we can check for os.path.exists. So as you are in the current directory, you can check like folder. It is saying true, right? So if not os dot so path dot exists of folder 1. So os dot make dir of folder 1. So this is how you need to execute. Then if it is not created, then it will create. Else it will not create. Similarly, if I do the same statement, it's like say folder 3. So folder 2 created like that, right? So folder 3 if I create. So you see here. So os dot make dir. Sorry, make mkdir. Sorry, my bad. So here also mkdir. Okay. You see in this case what will happen if I execute? It is creating folder 3, right? So instead of doing these two together, there is something called as os dot make dars. Make dars of. So if I say like folder same 3, and there is something called as exit OK is equal to true. Means if it is already present, just execute, that's it. You don't do anything. So if I say false, then it will throw an error. So sometimes if you want to throw an error, then you can do. Similarly, if I want to create a folder 4, as it is not present, it checked and it created. So that's the beauty of make drs. So compared to these things. And not only that, it can do multiple other things. So 4 is there. Within that, like, subfolder you want to create. Subfolder 1 I want to create. Under like subfolder, like, so folder 1 I want to create. Means within a folder, another folder you want to create. Now you see, under the 4, one more subfolder is created, another subfolder is created. So that's how. And see here, if you want to navigate to this within it, I can go like that and do it. So similarly, if I do the same thing again, as it like, so it is already present, it will not throw any error. It will just do it. But if I do like exit OK is equal to false, if you don't give, then it will throw an error. So like this, it will create a directory or 2-3 directories like this. Similarly, this kind of path, if you want to create, so how you can create? there is like either, see, folder 1, folder 2, folder 3, like that if you have 3 paths. So how you do in real time? So folder 1 plus you write a slash. So folder 2 plus you write a slash. So don't you think like it would be irking every time? You need to write a slash plus, so folder 3. If I do like this, then I will get a path, right? Okay. If it is Linux, if it is Windows, you write like this. But if it is Linux, the same thing you need to write like this slash. So they're like, so this slash you need to write. But Windows path is like crazy every time. So whenever you have like this, you need to replace with the 2 slashes. If I do 2 slashes, then here also 2 slashes, then it will work, right? This is what you know. So, okay, I don't know whether it is Windows or Linux. Based upon the operating system, it should do. In that case, instead of these slashes, there is something called as os.sep. Similarly, here also, whenever there is there, os.sep. If I do right now, did you see? As it is a Windows, it is showing like this. If the same thing is a Linux, it will do the other slash. It will create on its own. Sir, even this is also fine. But creating this kind of path, if there are 10 or 15, would be crazy, right? So then like os.path.join is another module. So another thing. For that, if you pass like, so like a list of things, say it will create on its own. The same folder 1, same folder 2, and like folder 3. If I pass like 3 arguments, so expected string bytes, sorry, not list. Okay. 1 second. Oh, sorry. It will take directly. Yeah, sorry, my bad. So it will take loosely. So whatever you pass, it is doing like this. So don't you think like os.path.join is good? Okay, you created some path. Now this path you want to assign to this. Say like, so new path is equal to this thing. And you want to check whether it is present or not. So os dot, so earlier we did path dot, so exists. So if I do exists of like new path, so then we know it's like it's false, it's not there. So you create any path, it doesn't mean it should be there. If you want to create that, os dot, so make DRs of, so that new path, and if it like exists, so okay is equal to true. Then see here, it will create a new directory structure. You see here, so where it is creating at this level, it will folder 1, folder 2, folder 3. And if I want to navigate to the directory, os.chdr of that new path, if I give, it will go into the directory. So if I say os.listdir, as there is nothing, it will just do. So till now you worked on only the folders, but you till now never gone on the file operations, how to create a file and so and so. So there are like 2 ways of doing a file operations, like file opening a file and adding the files and so and so. So there is one legacy way of doing that. One I will show. That is with the OS module. Earlier, way back in Python 2, we used to do like this. Even in before also, we used to do. So like os.open, you give any file name and you need to write the write mode. Means we are writing a file, right? So if I do, then it will execute. Now if you see, within that, it will create that file and it will do it. So and similarly, there is another ways. Means like I will tell you this afterwards much more clearly. So when you want to do, when you're doing your file operations, but here just to know, so there is another way. This is the most common way everyone does. Open is a built-in function. For that you pass the file name and you do the write mode. Means I want to create a new file, right? Then we need to say write mode. Then you need to execute. So wherever you create, it will execute. Now you see, earlier when I created, it didn't create because this was an absolute. Nowadays, so there are no more there involved in it. So whereas here, so it is saying like I cannot use it, right? Fine. it is opening also for me in a different directory. That's fine. So nowadays everyone uses this second way. Okay, once you create it, then we can read it. After creating a file, so the next thing is we can read the file. So how do you read the data from the file? The same thing. So same like how you open. Again, I do the open. This time the file name, and instead of write, I need to say read. Then there is an operation called as dot read, and we can read the file from it. This is how you read a file from it. Similarly, so there is like if you want to rename a file, so you created a file, then how do you rename a file? So you can see here text file dot file. If I want to rename it to say my text date file dot file. So what it says, hey, this process accesses the file as it is being used by another user. Means I need to have permissions to do it. If I have permissions, I can do it. So maybe like I don't have some permissions, it is saying that. So then, so going back, if I say like os dot list dir, again, I have these things. Now I want to delete these files. Os dot, there is something called as remove. Remove is there. Remove is there. For that, if I say, hey, text file.txt, what is saying? Still, I don't have the permissions. That's what it's saying. If I have permissions, it can remove it. And similarly, I want to go back, right? os dot chdir off. So I want to go to like, so 3 levels up back again, os dot get current working directory. If I do, I'll get the file directory. And if I say os dot list dir, you can see that list of files and folders. And now see here, os dot, so rmdir, so there is something called as remove directories. They created this one, remove directories. For that also you can give, say like, folder one. What is that? You see, there are two ways of removing. Rm is a command in Linux. So rm means like remove a directory. So for that, if you pass any directory, it will remove it. Similarly, here, if you want to remove, os dot remove. So remove is there, and remove directory, remove, right? Okay. Okay, you see here, remove is there, remove ders is there. There are two things. If I say os dot remove of say folder one, if I execute, what is saying, I don't have permissions. If I have to have permissions, it will remove it. So that's what anytime permissions matters a lot, right? So whether if it is there, fine. What if the directory is not there? It is saying that I cannot find the folder. You see here permissions error came. It is different exception. Here file not found error. This is what happens when you do a lot of times. And similarly, os dot remove errors. So for that also, if I give like folder, a folder one, what has happened? Remove will ask for permission. Did you see DARS? Did I remove DARS? It didn't ask for permissions. It just removed. So if I say like os dot remove DARS, it is so powerful. So if I say like folder one, did you see folder one has folder two, folder three, and then text file? If I execute now, so what it is saying? So directory is not empty. So do you still want to remove it? So it has an attributes for it. So if you want to forcibly remove something, you can do that. So you have these attributes, you can use that. So it is like so rs hyphen r or like hyphen force, like that we have, right? Recursively delete everything like that. So similarly, if you go with like any other module, it will not ask permissions if it is empty. If it is empty, it will just delete it. That's it. Folder say 2 I have. So remove the errors. Okay. It will remove it. See? If it is there, it will just remove. So this is how you understood about how to create a file, how to remove the file, and all these things. Similarly, if you want to come back, there is one more thing about the commands. So executing commands. executing commands is another big thing. So till now, if you want to execute any commands, I told you earlier also, now also I will tell. Hope you remember, in any terminal, if you want to execute, there are commands like ls is one thing, so dir is another thing. So like this, commands are there. Not only that, if you want to check, so there is something called as ping. You want to check whether you can connect to Google or not. Ping google.com you do. Or like if I say ipconfig, if I do, I'll get the IP configuration of my system. If the same system command need to be done in Linux, I need to say ifconfig. So ifconfig is not working now because like mine is not a Linux machine. But if you do in Linux or Mac, ifconfig will give the results. So like that, platform based, if you want to execute some things. So for that only I created a script. Here you can see. So ping a site is there. You give the things, it will create a code. So you see here, if you want to clear the screen, I told, right? If platform sys.platform is equal to, it is selective import. See here. So if platform is equal to so and so, clear or so and so. And if you want to get the output, this is how you are running. And if I execute these things, first it will clear the screen. As it's not a script, fine. So if I write the same command in the interactive mode I showed you, right? Then I will show you a command also, how the things will be there. You see now, each time it is executing and getting the result as 0 or 1, 0 or 1. What is this 0 and 1? Means os.system will execute anything you give. Let's say I told you, right? ipconfig if I give, it is executing. Whereas if I say ifconfig, it says it is not there is. But this command works in Linux. But if I do anything wrong, it will not execute, right? Means there are two things. Any command when you execute, either it is successful or failure. If it is successful, the output result will be a 1. If it is failure, it will be a 0. See, every time when I'm running the commands, I'm clearing the screen and doing. Let me now do one thing. Let's say, see here, say b, so commands.py I created. And what are the code I wrote there? The same thing I'm writing in a Python script. Now if you see Python space b so and so, if I execute. So did you see, first it will clear the screen. That's why previous output has gone. So then like it is executing the hello yahoo.com. So yahoo.com means it will execute these 4 commands. So then like it is doing a Yahoo. So Yahoo it can't go. Then again it is clearing the screen. So that's why you got finally IP thing. So first one by one if I go, so you will understand. If I clear all these things, you see now. So every time when I'm running, I'm clearing the screen and running. You see now this time execute it. I didn't clear the screen. So clear screen function executed. It cleared the screen. Then like ping a site, yahoo.com has gone. Yahoo.com is good. It is going. Then I just doing ping a site as Yahoo. Just Yahoo means it can't go, right? So for that it's showing like this. You see each time how the output is. If I say print, you'll understand each time what's happening. When I just re-executing, that's it. See, for the first thing means for clear screen, output is 0. Because every time I'm printing the output, right? The command is executed successful or not. Then like I did yahoo.com. So it is pinging all the Yahoo, ping related commands. Then finally result is 0, means everything is good. But when I gave like Yahoo, it don't know. Then it gave the message, error message, means it printed, and I captured 1. Means, and then if I ask this one also, it will execute. If it is ipconfig, ipconfig is there, so it will execute. So if I execute it, hope we can see that now. So now what you can say is that os.system execute anything like this, but you cannot capture the output. Means ipconfig you executed, but the result you cannot take. I got this much result, right? Can I tell like what is the IPv4 address? I cannot tell. It will just execute a command, that's it. But if you want the result of this, that's where we need to go to the next module. which is the subprocess. So with this we can stop. So subprocess, what do you mean by subprocess? How it can help you? Subprocess is a module which will actually execute the command and also get the result also. So first, like os.system, how it works, I will tell. Then what is the maturity it can do also, I will tell. So let me go with one example.
Uday, sorry, I have to leave. I will resume on Monday.
Okay, so how the subprocess is working? If you see the subprocess, it will work exactly same like the other script, but the slight difference. First, if I say like .ipynb, select the kernel. So input os.system of the same thing, google.com. So like that, if you want to execute, so it will execute all the things and it is showing. Did you see in script mode when I executed, it showed the result, whereas it is not showing the result now because it will show in the IPython console. So, but not here. So you cannot capture it. Whereas if I do like import subprocess, and if I say like print of dir of subprocess, you can see a lot of attributes are there. Among all the attributes, the most common I will tell. See, subprocess process dot all. For that also, if you pass same thing google.com, you can notice that it is also executing. So it will also execute in the backend, but it will not show you. So you will get only the result. But similarly, if you want to capture the result, there is another way. So for capturing the result, so we need to create a process and do it. So for that, we have like two things. So P is equal to subprocess dot P open, means you are need to open a new process. And for that process, we need to give the command. So what are the command I have? My command is like ping google.com. And for that, I need to pass the other things like after shell equal to true, then std out. Std out means like if you just execute, you cannot capture it. So if you want to just like execute, I will tell you what is the shell equal to true and all these things, how they are doing, I will tell you. So after giving it, if I say p dot communicate, means only after doing a communicate, it will execute. This will create like two outputs. One is the output and other one is error. So at a time unpacking. So two things at a time. Then after that, so if you print these outputs, if I print like, hey, what is the output? And and what is the error? I can tell. So first, initially, let me print the output. If I execute, I get nothing. It will also execute the same command in the backend, but it is not executing. Sir, we didn't capture anything output because why it is none? Because we don't have any place where to store. Means there should be buffers where we need to store the values. So what is this buffer? I will tell you. Means when you are executing, you will get an output, right? The output, if you want, there is something called as std out is equal to subprocess dot pipe. We say pipe means it's like a just imagine like a cache space where it will store. You want to get the output, then you place it, then you get it. Sorry, I didn't place a comment here. If you execute, it is executing in the backend, then the output it is coming, and the output is in a byte string. So byte string you cannot process directly, so you need to convert that to your way. So for converting any byte string, so we need to do like decode. And if I execute now, you see now, if I execute, here it is executing the backend. You are capturing all the values. You got the output. From the output, you can split and you can get what all the values are there. So if you want to get the TTL values or bytes or total time taken, so everything you can do because it's a string. So if I do like string output, so dot split, so split lines, if I do, it will split into multiple lines. And if I'm interested in like, so what are the IP? So it means like first line only. So if I do like, so if I do like this, I get only the first line. So within that, I can go to the, split by google.com and then get to the corresponding things. So split and get it, whatever you want. And similarly, I give a command which has an issue. Maybe like, ping doodle.com, it's fine. If I say ping Google, it will throw an error. Similarly, if I say ping Google, it is an error. It won't work, right? So if I just do like this, it is throwing error, but you don't get any output. Then how about the error? Similarly, I try to do the error also. If I say the error, so to understand the error, if I say error, if I execute the error, but still error is empty, because similarly like this, for error also we need to capture it. So std error is equal to subprocess dot pipe. If I execute like that, I give the pipe. Now whenever error comes, error also will be captured and you get the output. Similarly, if you want to capture the error, as it is decoded, you cannot understand. So we need to convert to decode that. Then if I say, you see, in this case, output is not there, error is there. So like this, you can take any example to do. So based upon the operating system, you can do something and go ahead. So this is all about these commands. Next, we can see about the other commands in the next class.